Okay, so we should be recording now. And this should be the Zoom video conference for October the 15th. And let's get ready to write on the screen if all this still works. Okay, so we're writing on the screen. I think everybody knows we have a test 3 on Thursday and Friday. And it's going to be covering basically modeling and functions. And it's going to be all about linear functions, quadratic functions, and exponential functions. If you have worked all the homework and understand pretty much all the problems, you ought to be in very good shape. There's also the practice test. I assume everybody knows how to navigate the website. With the daily schedule, you can go ahead and see the schedule here. I basically got all the videos done all the way through probability. And I've got to start working on some for October 28th, but I'm pretty much ahead of time. Notice we have Zoom links and Zoom notes. We have all the videos that you should have watched. And after this conference is over, I will be inserting right here the Zoom video notes and the Zoom link. The other thing to look out for is practice tests. In fact, I guess I overshot here. Here is practice test 3, and there's a video on how to work practice test 3. All of these problems are basically the same kind that are in the homework. And on this conference today, I'm going to work some other problems that are very similar and answer any questions. But before we start, does anybody have any questions about any particular problem? Nobody has a question? Is everybody there?
No questions, sir.
No questions, okay. Okay, so let's get started. Now, we have talked about functions in general. And here is a definition of functions. And a function can be any kind of ordered pairs of x and y. It could be a diagram describing it, could be a table or graph, or even a verbal description. I think you've seen all of this. The x values are let me get straight. The x values are the domain of the function. And the y values, the output, is the range of the function. This diagram sort of can tell you how a function is set up. You have an input x and an output y. There is only one y for any input x. So if you told me you put in x equal 1 and got y equal 2, and also y equal 5, it's not a function. There's got to be a one-to-one correspondence between the input and the output. And that basically says that the graph of a function must pass the vertical line test. And let's just go ahead and draw the very simplest of functions, a linear function. Y equal mx plus b. You can see that if you draw vertical lines on the x-axis, it intersects the graph at only one point. And let's even go and look at a quadratic function. The quadratic function you're familiar with has a graph that looks like this, and it goes through only one point. And then finally, let's see if I've got room to put an exponential function. Could be going up like that, or it could be going down like this. So whether it's this one or this one, vertical lines only intersect the graph at one point. And here are some other graphs. Here's one that's a function. This is one that's a sine wave. We're not going to have any questions about a sine wave, but obviously a function that looks like this only intersects at once. Now, here's one that's not a function. For, say, a value x1, you can get this value or this value, so it's not a function. It's a nice diagram, but it's not a function. And then here is an elliptical curve, and it's not a function either because it doesn't pass the vertical line test. So it's basically a one-to-one correspondence. I would thank you all to collect all the notes for all of the sections. Make sure you have the equations that you need to calculate things like slope and the equation for a line. I think everybody's familiar with the slope of a line between 2 points, x1, y1, and x2, y2 is y2 minus y1 minus divided by x2 minus x1. And you could also write this as y1 minus y2 over x1 minus x2, but not, you can't reverse one of these, okay? So now let's work a problem. The other main equation for linear functions is if you have an equation of slope m passing through a point x1, y1, then you can write an equation using this formula. You take y minus y1 equals m times x minus x1. And actually, if you wanted to, if you had the point x2, y2, you could say y minus y2 is equal to m times x minus x2. So any point that you know is on the line, whether it's x1, y1, or x2, y2, or x11, y11, if you know the slope and one point, you can write the equation. Now let's see if we can write the equation for a linear function going through -4 and -6 and 8 and 3. But we can call this x1, y1. This would be x2, y2. And the slope we want to know first is y2 minus y1 over x2 minus x1 is equal to y2 is 3 y1 is -6. X2 is 8, and X1 is -4. Just be sure to check your signs here. 3 minus -6 is going to be 9. And 8 minus -4 is going to be 12. So the slope is 9/12, or 3/4. So the slope is 3/4. So now we can use y minus y1 equal m times x minus x1. I suggest you guys, be taking notes here and trying to work it yourself as we go. Y minus y1, y1 is -6. It's equal to the slope, which is 3/4, times x minus x1. X1 is -4. Everybody check my work, because I'm doing this sort of without a lot of notes. This is y plus 6 equals 3/4 x plus 4 equals 3/4 x. 3/4 of 4 is 3. And now we need to subtract 6 from each side. And we get y equals 3/4 x minus 3. Everybody agree with that? Let's see if I got it right. There it is. By the way, I put the answers here, but didn't show them on the first slide. Now I just pull. How many people saw the linear function or college algebra book I sent out to everybody?
I did.
Okay. I noticed it had a little bit more on linear functions and quadratic functions than the free textbook that goes with this course. And so I just looked in there and pulled out some more problems. Does everybody feel comfortable with working these problems? I pulled out 17 and 18 and actually pulled out the answers. Would anybody like to see these worked? Why don't I do 17? We have 2 points, 1/2 and 3/4, and 5/2 and -7/4. We want to write an equation for the line. So let's first of all calculate the slope. Is equal, let's call this x1, y1, x2, y2. Slope is y2 minus y1. Did somebody come on?
Yes, sir, I did.
Who is that?
Corey.
Okay, we'll let you in. Charge you an extra $20.
Put it to the bill.
You might want to mute yourself. Okay. Okay, so getting back to the problem.
Okay, we done.
Hello? I'm adjusting my screen a little bit so I can write on a little bit better.
She's got down, baby.
When you get it from me.
Okay, Y2 minus Y1. Everybody mute your mic, okay? I have a question. Fact. I basically, everybody's pretty much muted right now. Okay, good enough. Okay, so let's work the problem. Y2 minus Y1 is X divided by X2 minus X1 for number 17. Y2 is minus 7/4. And Y1 is 3/4. Divided by X2 minus X1 is 5/2 is X2 minus X1 is 1/2. So this is minus 10/4 divided by 5/2 minus 1/2 is 4/2, which is 2. So this is minus 10/8, which is minus 5/4. So the slope is minus 5/4. So now we use the equation y minus y1 equals m times x minus x1. So y minus y1. Y1 up here is 3/4 equals m, which is minus 5/4 times x minus x1. And x1, looking back here, is 1/2. So let's sort this out. We get y minus 3/4 equals minus 5/4. Well, let's just go ahead and multiply it out. Minus 5/4 x. Minus 5/4 times minus 1/2 is plus 5/8. So I'm going to add 3/4 to each of these. And we get y equal minus 5/4 x. And we need to add 5/8 and 3/4. 5/8 plus 3/4 is equal to 5/8 plus 6/8 equal 11/8. So it looks like we got it right, folks. All I can say is check your work, check your work, check your work, check your work. You need to tattoo that on your arm, your left and your right. Always check your work. Does anybody need to see number 18 worked? If anybody does, say yes. If you think you know how to do this or want to go back and do it later, here's the answer down here. And I'm going to send you out the notes. Okay, now you can have word problems that you have to write an equation that goes along with the word problem and answer some questions. You have a salesperson that's paid $200 per week plus 5% commission on her weekly sales of X dollars. Find a linear function that represents her total weekly pay in dollars in terms of X. And then answer the question, what must her weekly sales be in order for her to earn $475 for the first week? Well, no matter how much she sells, she'll make at least $200 plus 0.05 times X. That's 5% of her weekly sales. And if you want to write this with the X first, it would be W of X equal 0.05X plus 200. So this should be the answer to the equation. The other question was, what should her sales X be in order to make $475? That means that 0.05X plus 200 will have to equal 475. Now, I'm presuming that everybody here knows how to solve a linear equation. So we need to solve for X and be able to say that X equals some number. So we subtract 200 from each side and get 0.05X equal 275. And then divide each side by 0.05 and get that her sales need to be 275 divided by 0.05. That's 20 times 275. Somebody tell me what's 20 times 275. Or I'll get my calculator out. Nobody's telling me.
295.
Wait a minute, 275 divided by 0.05.
Oh, you said divided by.
But it should be 20 times 275. Should be 5,500. Is that what everybody gets?
Yes.
You can actually find her in.
Yes.
Okay. So she needs to have $5,500 in sales in order to
Make
So, by the way, I have the cut down here. There it is. Now, here's another linear word problem. And a publisher charges $22.50 to print a 600-page book and $15.50 to print a 400-page book. Find a linear function which models the cost of the book. It's a function of the number of pages make pages P. Well, I'm going to set this up as an X and a Y, to tell you the truth. X1, Y1 would be 400 pages, cost $15.50. And X2, Y2, 600 pages, cost $22.50. So the slope of this line is going to be y2 minus y1 over x2 minus x1 is equal to 22.50. By the way, that is $22.50 minus 15.50 divided by x2 minus x1, which is 600 minus 400. 12.50 minus 15.50 is $7 divided by 200. And I even remember how to do long division the old way, because I could do this on my calculator. Anybody remember this? I don't like to do this that much. So that's 0.035. Did everybody get that?
Yes.
Okay, that's about 3.5 cents per page. What it really comes out to, that's dollars. So we could say that the cost, of course they're saying do it in P, okay, P instead of X. So we could say that the cost C is going to be, well, we need to write the entire equation, folks. Let me get back here. We need to write the equation is y minus y1 is equal to m times x minus x1. And y minus y1, let's just do this one. Y minus 1550 equals m, which is 0.035 times x minus x1. X1 is 400. And so let's write this y minus 1550 equal 0.035x. Now we've got to do 400 times 0.035. That would be 3.5 times 4. Is that minus 14? Somebody check me. 0.035 times 400. Don't leave me hanging here.
I got 14.
Okay, so we need to add 1550 to each side. And we get this handy dandy equation that the publisher would have that says he's going to charge 3.5 cents per page. Minus 14 plus 1550 is $1.50. So here's the equation. And let's just see if is that right. 0.035p plus 1.5. Okay, we got it right. So how do we interpret this? It says that no matter how many pages you print, he's going to charge $1.50, even if you don't print anything. That's like the startup cost before he does any printing. And then he'll charge 3.5 cents per page. So that's a very simple linear function. Okay. The amount of radiation in a 1 kilogram sample of plutonium loses 33% of its radioactivity every 500 years. All we're asking here is the function linear, exponential decay or decrease, or neither? This is exponential decay, and your R is 0.33. In fact, it's minus 0.33. It's losing 0.33 every 500 years. That means that 1 plus R, your exponential multiplier, is going to be 1 minus 0.33 equal 0.67. So every 500 years, the amount is 0.67 times what it was 500 years before. And really, if you say A is the amount at any time T, and let's say it's 1 kilogram, which is 1,000 grams, times 0.67 to the T over 500. Does everybody see how we got that? Okay, let's look at this so you'll understand it. It starts at T equals 0 at 1,000 grams. At T equal 500, that's 500 years later, it's going to be 1,000 times 0.67 to the 500 divided by 500, which is just 1. So that's 1,000 times 0.67 equals 670 grams. So A at 500 is equal to that. So when it's 500 years later, it's down by 33%. So it's down to 670. So in 1,000 years, it's 0.67 times 1,000 over 500, and that's just 2. So it's going to be 1,000 times 0.67 squared, and 0.67 squared times 1,000 is going to be 448.9 grams, or approximately 449 grams. So every 500 years, it goes down by the same fraction, 0.67 times the previous 500 years. It takes a long time for the number of grams to get very low and the radiation to really not be all that bad. That's why having a lot of radioactive material, it takes a long time for it to get to where it's not going to be harmful. Next problem. The population of a town is 10,000 in the year 2018. It's decreasing by 100 people per year. The function is linear, exponential decay, or neither. Okay. Well, you know, it's decreasing. So depending on how it's worded, it could be decay. But it also could be a linear function that has a negative slope. Well, the way this is worded, the population to start off with is going to be 10,000. And then you're losing 100 people per year. So this would be the equation for the population of the town. Slope is minus 100. That's basically what this is saying. For every year, it goes down by 100. And then, so what is it? So we have an equation for T is the years past 2018. So if you wanted to know what it would be, the population in 10 years past 2018, which would be 2028, it would be 10,000 minus 100 times 10, which is 9,000. So we would expect it to be down to 9,000 in 10 years. Okay. A rock is thrown upward from the top of a 112-foot high cliff overlooking the ocean at a speed of 96 feet per second. The rock's height above the ocean can be modeled by the equation h of t equals minus 16t squared plus 96t plus 112. When does a rock reach its maximum height? What is the maximum height of the rock? And when does a rock hit the ocean? Now, I'm going to draw, here's the ocean here. By the way, you don't have to draw a picture, but sometimes it helps. The cliff is 112 feet, and you're up here and you throw a rock up, and it's obviously going to come down and hit the ocean. And they say the equation is this, and we want to know when the rock reaches its maximum height. Well, we know that this is the equation of a parabola. Remember, A is minus 16, B is 96, and C is 112. Because A is less than 0, we know that it opens down. And so it's going to have a trajectory that looks like this. It's going to go up, reach a maximum height. This is called the vertex. The axis of symmetry, or H, is the X value, or in this case, it'd be the T value of the vertex, which is going to be minus B over 2A. So you need to have this equation with you. It's going to be minus b, which is minus 96, over 2 times a, which is minus 16. Let me erase here. 2 times minus 16. So that's minus 96 over minus 32. Happens to be a really neat 3.0. So at t equals 3, reaches the maximum height. So we're going to have something, I don't have enough room here. Well, let's say it keeps on going, come on down. T equals 3 is the t or x value of the vertex. And so to find out when it reaches the maximum height, we need to calculate h of 3. And that's going to be minus 16 times 3 squared plus 96 times 3 plus 112. And let's see, I think I wrote this down, but maybe I didn't. Let's just write it out. Minus 16, 3 squared is 9, 96 times 3 plus 112. And I'll pull this out on my calculator. And I get 256. So the y value or the h value is 256 feet. So this thing goes up 256 feet above the ocean. And when does a rock hit the ocean? That's when h hits the ocean. When minus 16t squared plus 96t plus 112 equals 0. Well, that's just the quadratic formula. I remember writing it down in terms of x instead of t. X equal minus b plus or minus the square root of b squared minus 4ac all over 2a. And up at the top, you've got your a, b, and c. So x is equal to minus b, which is minus 96, plus or minus the square root of b squared, which is 96 squared, minus 4 times a, which is minus 16, times c, which is 112, all over 2 times a. 2 times a is minus 32. So now we've got to calculate this. And has anybody done this? That's going to be let me see. Oh, yeah. 9216 plus 7168 all over minus 32. So X is equal to minus 96. And this is going to come out pretty neat. The square root of 16,384 all over minus 32. The square root of 16,384 is 128 all over minus 32. So dividing minus 32 into minus 96 gives you 3. Minus 32 into 128 gives you 4. So that's plus or minus 4. So the answers are 3 minus 4 and 3 plus 4. So at minus 1 and 3 plus 4, I'm sorry, 3 plus 4 is 7. So at 7 seconds, it hits the ocean. So I think all the answers are right here. Takes 3 seconds to reach its maximum height, goes up to 256 feet, and hits the ocean in 7 seconds. Okay. Find the vertex Y-intercept, and I meant to say X-intercept of this function. The H value of the vertex is minus B over 2A, which is minus 4 over 2 times minus 1. By the way, A is minus 1. Always write out what the A, B, and C are. So this is 2. And F of 2, the Y value of the vertex is going to be minus 2 squared plus 4 times 2 plus 3 is minus 4 plus 8 plus 3 equals 7. So the vertex is at 2 and 7. And to find the X-intercepts, we need to use X equal minus B plus or minus the square root of B squared minus 4AC all over 2A. The B is 4, so it's minus 4 plus or minus the square root of B squared, which is 4 squared minus 4 times A times C, which is 3, divided by 2A, which is 2. So this is minus 4 plus or minus the square root of 16 minus 12 divided by 2 is minus 4 plus or minus anybody see a mistake? I think I made a mistake here. Minus 4AC. There should be a minus there. 4AC is minus 4 times the A is minus 1 So this is 16 plus 12, not 16 minus 12. And so let me correct that. Excuse me. So it's minus 4 plus or minus the square root of 28, all divided by 2. Taking it over here, that's minus 4 plus or minus the square root of 4 times 7. Divided by 2 is minus 4 plus or minus 2 square roots of 7 over 2. And that's minus 2 plus or minus the square root of 7. So the answers are minus 2 minus the square root of 7 and minus 2 plus the square root of 7. Okay, so that's for the quadratic minus x squared plus 4x plus 3. Oh, by the way, I had the answers here for the X-Intercepts. We'll write down the vertex was 2 and 7. Okay. Here's an exponential kind of increase problem. It's pretty bad if it's a flu epidemic. Flu in a very bad year increased at the rate of 50% per month. In the first month, there were 100 cases. How many cases after 6 months? Well, the thing here is it's exponential increase. And R, little r, is 0.5. So the growth multiplier is going to be 1 plus R equal 1.5. So the number of cases is going to be 100 times 1.5 to the t power, where t is months. So it's 50% per month. It's not 50% per year. So after 6 months, you will have 100 times 1.5 to the 6th power. And I believe I have that hidden down here, 1,139 cases. Because that's a pretty large growth rate. And I think this is the last problem. Actually, this is one on the practice test. A California home value increased rapidly at 15% per year. In 20 years, how much was a $100,000 home worth? Well, here again, the growth rate is 0.15. Notice an increase. The growth multiplier, you have to calculate that as 1 plus R, 1.15. So the price of the house in years past the beginning time would be $100,000, which is the starting value, times 1.15 to the 20th power. And that is going to be a big amount. I knew a lot of folks in California who made a lot of money over 20 years on their house, if they could afford a house to start with. And that ended up being $1,000,000 $636,654. So these basically the kinds of problems you might see on the test. Does anybody have any questions?
I don't,
Okay. I just noticed that Sandra Cochran came in. Sandra, how are you doing? I'm just marking you down. Let's see if anybody else is here. Well, I think that's it. Anybody can email me or text me if you need a little extra help sometime. We could even have a one-on-one conference, but just work the problems, work as many as you can. It's going to be linear, quadratic, and exponential functions. And I wish you all a lot of luck. Okay.
thank you.